Okay. So let's take our calculators. Go to y equals, press y equals. Make sure that the plots are turned off. I don't want them to be highlighted. Did I mention that already? I'm not sure if I did. None of the plots is supposed to be highlighted. Make sure you do that, or else you will, from time to time, get into an error message. Let's type this into our calculators. If you get a calculator, use it. So if the equation is given, type it in. So I'm going to go negative 4.9 x squared plus 35x plus 4. I graphed it. We're good. Okay. Now, let's make it appear on our screen. That is important. Okay. Listen carefully. You have a choice. You want to use the zoom features, or do you want to just adjust the windows? You want to customize them yourselves. That's up to you. I'm going to graph it and see what happens. Which way is this going before I even graph it? A is negative, right? It's doing this for sure. It's for sure. Okay, so let's graph it. Oh, I saw one of the legs on my screen. How about we all see the same thing for now? Zoom standard. Let's all have a standard zoom, a standard window. If you do a standard window, that's pretty good. But I'm going to chase the curve up. I'm going to change what on my window? Y max. Yes. I'm going to change it to, I don't know, 50. Let's try 50. Not good enough. Let's try it again. I'm going to go 80. I feel 80 works for me. Just change your Y max until you see that. Another thing that bugs me, I don't know about you, but if I see too much blank space that I don't need, it's a word problem, I get rid of this. So I go to my window, and my x min, instead of negative 10, I'm going to go negative 2, let's say. That way I don't see a whole lot of blank. Okay? All right. What is this word problem all about? Let's read it. It's the path of a baseball that has been hit. It can be modeled by this equation, where h is the height and t is the time in seconds. By the way, if you're new to applied, you'll never have to guess. This side is your x, and this side is where your y is found. Every single time. So in this particular case, every single x value refers to time, and every single y value refers to the height at that particular time. This is going to be very important that you don't mix that up. So let's answer some questions. We see it on our calculator. Now we can answer questions. What is the initial height of the trajectory of the ball? In other words, what is the height? At what height was the ball hit? At time t equals 0 seconds. Okay, that is the y-intercept. Okay, it's, if you want a little sketch on the side, are we starting on the ground or off the ground? Look at this. What does that tell us? What's the y-intercept? It's going to be 0, 4. So we're starting at 0, 4, and according to my calculator, this ball goes up and then it goes down, hitting the ground at some point. This is what I want you to think of as the initial height. Okay, so it's 4 feet. Because our height is measured in feet, you need to state that. Okay? How else can we find our y-intercept using our calculators? Let's say you draw a blank. Second, trace, value, let x be equal to 0, and if you hit enter, y is equal to 4. Okay, so that's another way of doing it. Determine the maximum height. What do you think it's asking us for? The vertex, yes. This is the vertex. Vortex. So second, trace, max. Guys, some parabolas are going to face up. Okay? I can think of an example where a bird is sitting on a branch and dives and gets a fish underwater and comes back out. So they're not always going to look like this, so you got to be careful, read carefully. The calculator is a huge help, right? So let's find the max. Do you remember how to do that? Second trace max. It wants something to the left of the vertex. I am to the left, so press enter. Right arrow over the hill. Enter, and enter one more time. I will write down the coordinate. Why should you write down the entire coordinate? In case you need to graph later on. Then you have that point. You don't need to go looking for it again. So the height is 66.5 feet. What does the 3.7 represent? The 3.7 represents the time it took to get to that highest point, right? So always remember, this is the time, this is the height. How long does it take for the ball to hit the ground? What are we asking? What is it asking for? Imagine, right? It gets hit, reaches the maximum height, and drops to the ground. It's asking for this x-intercept. So how are we finding the x-intercept? y2 is equal to 0. Second trace intersect. So let's go ahead and find that. We let y2 equal to 0. You hit graph. This is the x-axis right here. So we want to find that intersection there. Second, trace 5. Go closer to that one. Hit enter 3 times. It's 7.260. Okay. This isn't good enough. Okay, you have to go 7.26 seconds. Okay, for you to get that one right. Does it make sense, guys, or does it make sense? This is the point right here. Okay? Just so you know. That's the x-intercept, which has that combo. That's the time it takes, because x is the time we're after here. Calculate the height of the ball at 1.5 seconds after being hit. That's second, trace, value, x is equal to 1.5. We will find out what the y value is. Because this question is essentially giving you the x value, and you want to know the y value that goes with that x value. So grab your calculators, second trace value, x is equal to 1.5, and there it is, 45.48. Can you see it? 45.48. Okay, you circle that, you put units next to it, and you're good to go. All right? Determine the time the ball remains at or above 49 feet. What is that saying? Right, greater. So let me give you a little sketch here. The ball gets hit here, reaches maximum height, comes back down. Let's get ourselves a reference. Let's graph that 49 line to know where is 49. Okay, so go to your calculator. They're giving you the indication of a height, which is our y value. We're going to type in 49. We're going to graph it. And it happens 2 times, right? you hit 49 on your way up, and then it hits 49 on its way down again. So we're interested in how much time went by from here to here, right? Like how much time has gone by. So we're going to figure out this first intersection, write down the time, and then find the second intersection, find that time, okay? And then subtract them. So graph the 49 line right here. This is time 1. This is time 2. I'm going to write down my time 1, and I'm going to write down the time 2 right on the side here. So what do we do to find the intersection? Second trace, intersect. I'm going to find the first one, enter 3 times. It's hard to see, but it's 1.6816. I'm going to write down 4 decimals because I'm not done yet. I'm going to subtract them, so I don't want to round too soon. So 1.6816 seconds to get to it on the first time, at the first time. Let's find it one more time. Second trace 5. I will go and find that second instance. And that is 5.4613, rounded to 4 decimals. Have you seen delta t before? Delta means subtract. So we'll subtract the second time from the first time, and then we know how much time went by in between these two. So that would be 5.46 something minus 1.68 something. Yes, that is okay to do the dot, 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 because you're telling us you're using more than 2 decimals. I know it's really crowded here, I apologize, but that's 3.78 seconds. Let me just tell you this. If you have to do this much work, it is definitely a 2-mark question. Something where you're not just finding one time, you have to do multiple times and then subtract, 2 marks for sure. All right, let's graph this thing. If you've been with me in Applied, you know that we do a lot of graphing. I want you to be really good at it. There are 3 things you want to be looking for: labels, scale, and points. You want the points to be where they're supposed to be. Sometimes we call that shape. So you're basically going to make the graph fit, guys. Okay? You're going to make it fit. So what's the greatest x value I need to account for? The greatest x value for me is when you hit the ground, 7.26. So I'm going to try this. 1, 2, 3, 4, 5, 6. No, I'm running out of space. So I'm going to try something else. 2, 4, 6, 8, 10, and so forth. Sorry, the graph isn't quite on there, my bad. And make sure you write time and seconds. If you want full marks, you have to label and indicate the unit we're using for that axis. What's the highest I get to vertically on my y? It's the vertex, right? 66.5. So if I get up to 70 or 80, that will work for me. I'm going to try that. 20, 40, 60, 80, 100. Works perfectly. What if I went up by 10? 10, 20, 30, 40, 50, 60. It would work, but it would be a bit tight. So I'm just going to go up by 20s. That's good enough. And where do I label? It's going to be a little crowded here, but I'll just go height, and I'll write down feet. Either at the tips or on the side. It's up to you where you want to do it. And I think it's a good idea to put arrowheads on your axes here, Because this, you're saying that it continues and it continues also up here. And now plot your points. I already made you find all the points, but if I didn't, please find the important points. Which are they? Intercepts and vertex. 0, 4 is, this is 10, right? This is 5. So 0, 4 is right about there. That's my y-intercept. And my vertex is at 3.57, right? So this is 3 for me. This is 3.5. That's close enough. I'm going to go up that line until I get to the 60 line. This is 70. This is 65. 67 is right about there. Did I say 67? It's 66.5. Anyways, you get it. You get it. 67. Okay. And then the 7.26. This is 7. This is 7.5. 7.26 is right about there. And I always go to my vertex and go to either end. So I'm going to go vertex down to the y-intercept, vertex down to the other x-intercept. Question. Those of you that are not falling asleep yet on me, okay, should have one of those, like, anyways, whistle. Is it okay to do this? It doesn't hurt. Don't do this. Don't copy. It's okay. It's just gonna like do this just to be safe. You would lose a full mark for that. Yeah. Because what are you saying? If you're going this way, what are you saying? That time is negative. Can't have that. And you're also not digging in the ground. Like there's no indication that you're. So, you know what? Like nerdy teachers would say, it doesn't, it violates the domain and range. That's what we would say. Among the elite, right? I'm just kidding. We're not elite at all. But that's what the province would say. Domain and range is being violated there, so it's not. Okay. So one thing that's missing, I would just make sure you label the equation somewhere on there. Okay. G. State the domain and range of this scenario. Let's just do set. I might do both just so you guys. Domain, guys, the lowest I ever get to in terms of my x values is times 0, right? Inclusive. It goes. Right, the ball is in the air until it hits the ground. When does that happen? 7.26. Inclusive. Both ends are included here. Range. What's the lowest the ball ever gets? 0. Did you hear that? It's not 4. A lot of students are like, oh yeah, 4. 4 to the highest. But remember, this does hit the ground. So 0. And the highest is 6. I wish it could have made it 67, right? Why didn't you, Mr. Dirksen? Because this question was made before the phenomenon of 6-7. Okay, so that's your domain and range. If you love your set notation, the only thing I'm going to tell you is you must use the letters that the equation is using, which is what? T and H, correct? Instead of X and Y. So this is how it would look. Zero to 66.5. I'm going to skip H for another day. But what about I? Write another equation that would model the path of a ball with a lower maximum height. Remember? Yeah.
I was also taught, like, whenever you have domain and range, whenever it's like 0, it's It's not a square bracket, it's actually a curve. Is that true?
That is only if there are certain instances where we have a round one, if 0 is not included, but times 0 is actually included, and it hits the ground, so 0 is also included.
So for this question, it is, but for like most, it won't.
Most it will be. Very few it will not. We'll talk about something called the asymptote, but not in this unit. When we do exponentials and logarithmics, that's when you have to watch out for that one.
So which ones would it be curved?
When 0 is not included, which is when there's going to be an asymptote.
Like how
I'll talk about it when we get there. But for now, just I think you're safe to just put square brackets on word problems on either end. Hold on. Before you go, what would we do? So this is what I'm asking you. Write me another equation, blah, 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 with a path that would model a path that's lower than we want the current scenario. What would we do to have a parabola? Like basically what we want is this. We have this. We want one that's lower, doesn't get as high. Change your, I would just change my constant. I would lower that. It used to be 4. I would make it 3. Or let's be really nerdy here, okay? How's that? It used to be 4. Now it's 3.99. It's going to be slightly lower because you're shifting the entire curve downwards. Okay? How? Did you ask how? Oh, I thought you said. Okay. Hold on. Your homework is just 26. I want you to try 27. If it doesn't go well, that's fine. So I'm just going to say page 26.